So this is the integer and binary programming problem from the Operations Research 1 course. Monsanto annually produces 359 million pounds of the chemical maleic anhydride. So they have 4 reactors and each reactor can be run on one of 3 settings. The cost is expressed in thousands of dollars and pounds in millions. So those are in table 99, and it says that a reactor can only be run on one setting for the entire year. And we have to come up with a solution to tell Monsanto the minimum cost to meet its annual demand. This is a problem from the Winston Operations Research. So first we have to the implemented model. We have to meet the sets. So we have 4 sets, index I, 3 settings for each reactor, index J, and we have parameters. So each cost is given in table, and the same with productions. For example, I equals 1 and J equals 2, that means C sub 1 2, and that must be, for example, reactor 1 setting 2, so the cost for that specific value is 80, and the annual demand that we have to meet. The objective function is some minimize cost, and the variable is 1 if the reactor and I functions in setting J, 0 otherwise. So that mathematical expression means that Yij belongs to the set 0 1, so that means that Yij can only take or 0 or 1. For that we have to meet the minimum cost function, the objective function. So we need the cost, so we have to sum all the cost times the y variable. So if it's 0, it's going to be the cost times 0, which is 0, and if it's not, it's going to be the cost times 1, which is the same cost. So that for all the prices. We have to know a constraint that is that each reactor can be set in either one or none configurations. So that means that each reactor can only have one configuration, and this is the mathematical constraint. And there's other constraint that we need to apply, that is the demand satisfaction. So we cannot produce less than the demand that Monsanto tells us to meet. So this is the solver method in Excel. We give its values. The y variable matrix, we initialize the y variable matrix in 0. We give the constraints and the objective function constraint and the total production. So let's see. This is the constraint. Let's initialize again this in 0. So this is the table that we have originally. So this is the restrictions, and we solve it. There's one solution. So this is the solution. That means that y11 is 1, y32 it's 1, y43 is 1, and the other values are 0. So this is the values for which Monsanto produces the minimum that they have to require with these constraints, and for that it's almost 363 millions of pounds of the chemical. And that's it.